Welcome back, ladies and gentlemen. Today we're going to tackle section 10.4, day 2. We're going to talk about theorem 10.10 today. On the screen you'll see your exit question as usual. Theorem 10.10 is pretty simple. All it says is that if you have a quadrilateral inscribed inside of a circle, that opposing angles within that quadrilateral are supplementary to each other. I can prove that to you, or at least demonstrate that, by jumping over to Sketchpad here, and you'll notice that measure of angle E and the measure of angle G are being measured. And if I play around with where this point D is along in this circle, and this can be any circle with any quad inside of it, you'll notice that the angle of E and G change, but they remain supplementary to each other. Going back here, that's exactly what the theorem says. We're also going to hit up theorem 10.7 a little bit harder today. I want to do just a couple examples and just brush up on a little bit of notation. In the book, they're going to use labels like this that says 56 degrees, and it's kind of just floating out there, and that confuses a few people. So I just wanted to draw your attention to what they're trying to say there. If you see a floating degree marker out there or a floating variable expression out there, what they're trying to say is that the measure of the central angle associated with that chord or associated with that intercepted arc is whatever they put on their floating label there. So 56 degrees in this case. The inscribed angle is half that, just like theorem 10.7 says. So if they put a number that's floating out here, they are again going after the central angle, not the inscribed angle. All right, on to our first example. Here it is. You may want to copy the drawing real quick. It does not have to be perfectly accurate. You can pause the video and do so. All right, our goal here is to find the measure of arc VST. That would be this guy right here, VST. And you're going to have to use one of your theorems from today or yesterday to do that. See if you can pause the video and figure out how. All right. First thing to get started here is that you notice you've got an inscribed angle right here, and you know that the intercepted arc that's associated with that inscribed angle should be double that, or 102 in this case. So theorem 10.7 says that 102 is right here, and from there you'll notice that all of the circle is described, the outer bit of the circle is described except for this segment, this arc ST right here. So if we just consider the fact that the entire circle would be 360 degrees through a little simple subtraction, we can figure out that the measure of arc ST must be 84 degrees. So therefore, VST, that minor arc, must be the sum of 39 and 84, which is simple enough to add together. On to our second example. This one is complicated, so I would really appreciate it if you took the time to copy down the drawing in your notes and ask yourself the question, what is the value of x? See if you can go ahead and solve this. If you can't, try that, pause the video right now, and if you can't, I'll give you a hint in a couple seconds. All right, my hint is to write two equations that involve the measure of angle n. So see if you can pause the video and see if you can write two equations that involve the measure of angle n. Okay, if you've given up on that or just stuck, here are two possibilities, or you can check your answers hopefully if you've got it correct. Now what you'll notice about this arc KLM is that it is associated with this inscribed angle KNM. So the inscribed angle n is associated with this arc 171 and 7.5x. So you know that the sum of these two must be double what the measure of that angle is. So you can write an equation to that extent, or angle n is half the measure of the intercepted arc in this case. So you can write one equation like that, and the second equation that you can write will be using theorem 10.10 from today, which is simply that 12x plus the measure of angle n must equal 180. So you get two equations involving angle n. They also have an x in it, so you have two equations, two unknowns, which means you need to solve a system of equations, which is best done if you either substitute, or in this case, they're both got that measure of angle n sticking out there pretty good, so we could just move 12x over here like that, and now we've got the measure of angle n equals this, and the measure of n equals that. So that means we can set those two equations equal to each other and go at it. In solving this equation, maybe a little new technique for you to know, Maybe not, but you might be tempted to distribute that 0.5. I don't like dealing with decimals that much, so I multiplied both sides of the equation by 2. That gets rid of the 0.5 on the left-hand side and doubles everything on the right-hand side of the equation. From there, it's just a matter of combining like terms and solving. You get a value of x equals 6. Up on the screen, you'll see your homework for the next day. I will see you next time.